So another way solution concentrations can be modified is by mixing together multiple solutions that have different concentrations of the same drug. In this situation, you would sum the amounts of drug that are contributed by each solution to get the total amount of drug, and then you divide the total drug amount by the total volume. Or if you're working with a solid preparation, you divide by the total mass. And that would give you the new drug concentration. So to get the amounts of drug in each solution that you're mixing together, you could set up proportions for each one, or you could just do what we did when we talked about the dilutions equation, where you can multiply a concentration by its total quantity, and that will give the amount of drug. So we can multiply Q and C together for each one of the solutions that we're mixing together, and that sum of QC products represents the total amount of drug. The total quantity will come from summing together the volumes of each of the solutions that were mixed together. Q1, Q2, Q3, and Q4 will be summed together, and you'll get the total quantity from that. So one thing to watch out for, though, is that in some problems, the total volume will be larger than the summed volumes of the individual solutions. And that can occur when you're adding some additional diluent that doesn't contain the drug, just to top off the solution to some specified volume. So carefully read the problem and watch for any additional volume that's contributed by other solutions or diluents that don't contain drug. Otherwise, you can take the total sum of the QC products, the total quantity, and divide them, and that will give you the concentration of the combined solutions. This procedure is called Alligation Medial. So in the example problem, we want to know what concentration will result from mixing 9 mils of a 10% solution, 2 mils of a 20% solution, and 5 mils of a 30% solution. They all are concentrations, different solutions of sodium chloride. So the amount of sodium chloride in the first solution will be represented by multiplying the volume, the quantity, times the concentration, the percent. And you can turn these into decimals if you want, or you can leave them as percents. Just make sure you keep track of which one you do. It will determine whether you need to multiply by 100 at the end or not. So if we keep it as a percent, we don't need to multiply by 100 at the end. Second quantity concentration is 2 mils of 20% to get 40, 5 mils of 30% to get 150. So all these represent the amounts of sodium chloride, and we just sum them together to get 280, and this is in strange units, mils percent, because we left it as a percent. Total quantity in this situation, there's nothing extra added, so we'll just add 9 plus 2 plus 5, the mils of each solution, to get 16 total. So 280 mils percent divided by 16 is 17.5%. Okay, go ahead and try this, this Alligation Medial problem. Work it out in the next video.